Well, problem 1 is very similar to the problem that we did in examples, in which we have 2 smaller triangles and 1 larger triangle. So you could see that I have color-coded the angles there that are corresponding, and so that this S angle here is going to correspond with the Y angle here. And so if you need to draw those out separately like we did in the example, that may be helpful for you. But what we find out is that triangle SRT, which is the large triangle, is similar to triangle YRS. You could see how I've marked the pink angle and the blue angle, and that is going to correspond to or be similar to triangle YST. So we have to be careful here that we went YRS, and that here that we go YST. What we can see then is that the proportion that we're looking for is that we need to fill in that that RY is going to be in proportion to YS, and that's going to equal YS equal to YT. YT is the part that we don't know, so that is our X. If we fill in the other numbers there and we cross multiply, we get 12x equals 169, and divide that, and we're going to get that X is approximately 14.1. In problem 2, we have Mel is standing next to a statue in a park. Mel is 5 feet tall, so here's Mel 5 feet tall, and her shadow is 3 feet. The statue shadow is 10.5 feet long, that's right here, but we don't know the height of the statue. And so we're going to set up our proportions here, that the height of the statue is in proportion to Mel's height, so x over 5, and then the shadows proportion to each other, so 10.5 feet to 3 feet. And so when we have our proportion, then we're going to take and cross multiply, and when we divide, we're going to get that the statue is 17.5 feet tall. In problem number 3, we have a 26 foot rope from the top of a flagpole. It reaches the end of the flagpole's 10-foot shadow. So here's the top, here's the 26-foot rope that reaches the end of the 10-foot shadow. How tall is the nearby goalpost if at the same moment the shadow has a shadow of 12.5 feet. So we don't know how tall the goalpost is, and here is the shadow. So this is what we're looking for, but we need to start over here with this triangle, because we're told that this rope coming down is 26 feet, and that this shadow right here is 10 feet. What we need to figure out first is this side, and since what we have here is a right triangle, we can use Pythagorean theorem to figure out that this side is 24. So that's our first step in the problem, because we need this side to be able to set up the proportion with this side. So once we do that, we can have 24 over x is equal to 10 over 12.5 to set up our proportion, and then cross multiply and divide to find out that the goalpost that we're looking for is 30 feet. Right, in problem number 4, we have 5 foot Melody, which is right here, cast a shadow of 84 inches. Notice that I turned those inches into feet, so that's 7 feet. We want to know how tall is her friend if on the same day his shadow is 1 foot shorter than hers. So how tall is her friend? There's our x right there. If his shadow is 1 foot shorter, so if this was 7, 1 foot shorter is 6. So our proportion is 5 to x. So 5 to x is equal to 7 to 6, 7 to 6, and we cross multiply and divide, and we get that he is 4.3 feet. If we needed to, we could figure out how many inches that is, but we can leave our answer just like that for right now. All right, in problem number 5, we have Juanita, who is 1.82 units tall. She wants to find the height of the tree in her backyard. So this is her tree, and she walks 12.2 units right there along the tree shadow to a position where the end of her shadow exactly overlaps the tree shadow, which is right here. And she is now 6.1 units from the end of the shadows. So here's the end of the shadows. Here's where she is standing right here. Here is her height. Okay. And so now what she wants to know is how tall is the tree. So what we need to look at first is to take, well, the height from the tree to where she is standing is 12.2, or the distance, and then the distance from where she is standing to the edge of the shadows is 6.1, and so we need to add those together to get the 18.3, and then we have enough information to set up the proportion. We're going to say the height of the tree, x, is proportion to the shadow length, which is 18.3, and that is going to equal her height, which is 1.82 units, and then her shadow, or the distance between her and the end of the shadow, which is 6.1 units. And if we cross multiply and divide, we're going to get that the height of the tree is 5.46 units. All right, in this problem, we have Private Eye Samantha places a mirror. So the mirror is going right here on the ground between herself and the apartment building. So this is Sam over here, and this is the apartment building. Okay, so she is 1.1 units from that mirror. So here's the mirror. She is 1.1 units from there. If we look here, then from the mirror to the base of the building is 7.32 units. That's right here. Samantha's eyes are 1.8 units above the ground. So what we're thinking is she is here and she's trying to look over here, and we're looking to see how high the building is. That's Rx. And so we now have enough to set up our proportion that we're going to have 1.82 to our unknown height of the building, x, and that will equal 1.22 to 7.32. And so this is just a cross multiply and divide, and we get 10.92 units for the height of the building. All right, in problem number 7, Francine has a camera in which the distance from the lens to the film is 24 millimeters. So here is this is her camera. Here's where the film would be. This is the lens, and that distance is 24 millimeters. If we continue on, she's going to take a full-length photograph of her friend. Her friend is 3 meters away, and because we have millimeters and meters and centimeters, the hint here is to convert everything to millimeters. And so that 3 meters away is going to become 3,000 millimeters away. Her friend is 140 centimeters tall, which is then going to become 1,440 millimeters tall. What will the height of the image on the film be in millimeters? And so what we're looking for is this over here. And so now we have enough to set up our proportion. So we would say that x is proportion to 1,440, and that's equal to 24 in proportion to 3,000. And if we cross multiply and divide, we're going to see that that's 11.2 millimeters. All right, looking at problem number 8, it's a little bit of a variation of problem number 7. This time we have that we know that the distance from the lens to the film is 24 millimeters. So this is the camera, here's the lens, here's the film. This is our 24 millimeters. Suppose the height of her friend in the image on the film is 15 millimeters. And so here is the image, the picture, 15 millimeters. And then it says that she took a full length shot of her friend. So this is her friend over here, and her friend is 140 centimeters tall, which we're going to have to convert to millimeters. And so we are looking at the distance between the camera and her friend in meters. So this is the distance that we are looking for here. But now we have enough to set up our proportion. We're going to be able to say that our first proportion, 15 to 1,400. And then the second part, 24 to that X, that measurement that we're missing there. When we cross multiply and divide, we're going to get that X is 2,240 millimeters, but then it asks us to find the answer in meters, so we're going to have to convert that to 2.24 meters. All right, in our next problem here, we have two rectangular desks. If we look at the first, or the larger one is 42 feet long and 18 feet wide. The smaller one is 35 feet long, and we're looking for the width of the smaller desk. And so I'm going to say this is X to 18, so X to 18, and that's going to equal 35 to 42 right there. And so then if we cross multiply and divide, we're going to find that the width of the smaller desk is 15 feet. In problem 10, Jimmy has a die-cast metal car that is a scale model of the actual race car. If the actual length of the car is 10 feet 6 inches and the model has a length of 7 inches, what is the scale factor of the model to the actual car? So our model is 7 inches, and then the car is actually 10 feet 6 inches. And so our first step is to convert those inches, or this measurement, completely into inches. So we would have now the 7 inches for the model car, and then 126 inches for the length of the actual car. And when we reduce that, we're going to get 1/18. So the scale factor is 1/18.